Hello, Internet. We're coming to you with another tech talk from DigitalOcean. This is improving the Kubernetes experience and eliminating toil and tribal knowledge. I am Ben Gadbois. I'm an engineer on the DigitalOcean delivery team. We are live on YouTube, Twitch, Facebook, and LinkedIn Live. So if you're watching, throw where you're coming from because we know this is a big global show. We'll be monitoring questions in the chat, drop them in, and we'll sort of intersperse them during the talk. So I'd like to introduce Billie Cleek. He's a staff engineer here at DigitalOcean with a talk for us.
Thanks, Ben. Yep, so I'm Billie Cleek, I'm staff engineer at DigitalOcean. I've been at DO for a little over 4 years now. I started out on the delivery team where Ben is as well. And now I'm a staff engineer for the entire patch group. So we do things like some internal Kubernetes platforms, DOKS, Marketplace, DBaaS, and sure there's some others I'm forgetting, Ben. App platform is a very popular one right now. Today we're going to talk about eliminating toil and tribal knowledge and just simplifying the Kubernetes experience. What I'm going to do is talk through a basic experience and so a platform that we have internally where we've leveraged a lot of these techniques, and then I'll show you how to implement this. I wish that this could be a live coding demo, but there's a little bit too much here to kind of do in the amount of time that we have. So I'm going to show you the effects here in a few minutes, and then we'll get into exactly how to make those happen in Kubernetes. And if you have any questions, please make sure you type them into the chat. Then we'll make sure they get relayed to me, and it's totally fine to interrupt me and ask questions if I need to clarify anything or slow down or go back over anything. All right, so I'm going to start out with telling a little story. So internally, DigitalOcean has a platform built on top of Kubernetes. So it's been said that Kubernetes is a platform to build platforms, and DigitalOcean did just that back in 2016, 2015 timeframe, and built a platform called DOCC. And DOCC is an opinionated platform built on top of Kubernetes. So users get a lot of the experience of Kubernetes. You get automatic replication. You get just container scheduling. It's of course container orchestration. So DOCC takes like what could be many hundreds of lines of YAML and reduces that down by usually about a third or so. And it's specified in JSON. One of the nice things about DOCC is that you don't have to worry about things like group version kinds. You don't have to, if Kubernetes is deprecating something, our users don't have to write that. The DOCC team takes care of all those kinds of migrations that need to be done. Also, there are a lot of features of Kubernetes that most users are just never going to use. And so DOCC just hides that away from all the internal users, so they don't have to learn all those particulars of Kubernetes. And today we're not going to talk specifically about DOCC, but we are going to talk about some of the techniques that we've leveraged in DOCC to make sure that environment variables get injected that our users can rely on, so they don't have to know what those environment variable values should be. Also, so that we can change them if we need to. Those environment variables do things like describe the region or the data center where an application is deployed. It might describe the service domain or the cluster domain for the cluster, in case people need to know that, to construct fully qualified domains for other services they expect to be running in the same region or in the same DOCC cluster. We can also do things like inject a syslog socket or mount certain secrets and certificates into pods. And so all that's just kind of abstracted away, which really reduces the amount of boilerplate that people have to put into their Kubernetes or DOCC manifests, so that they can just focus on doing only the things that they need to do, and they can know that all those other features are going to be there for them. And also, like I said, it gives the DOCC team a lot of freedom to move things around if they need to change it up. Worst case scenario is, they change something in the DOCC clusters, and they might have to do some rolling updates of running applications, and users don't ever have to be any the wiser. So, all right, so let's get into it. I'm going to show you a quick example. So we have an example application that I've created here. And this deployment right now is relatively straightforward. If you're not familiar with Kubernetes, or if we need to slow down and explain what anything is, feel free to ask in the chat, and we'll go over it a little bit. This will be very focused on Kubernetes, and we're also going to talk a lot about Go. Before I start talking about Go, I'll give you some rationale for that as well. The important thing to know in this deployment is that it only has a single container. That container has resources set up to limit the amount of CPU that this application can use. There are no environment variables set, and it just does a very simple infinite loop to spit out the host name. No big magic, nothing terribly useful, other than a small deployment that we can show that how we can reduce some toil and eliminate some tribal knowledge here. So again, remember, this is a very, very simple application, but it's going to work well to demonstrate what we want to show here. So first thing I'm going to do is I'm going to scale this application up to a single pod. I'm going to go grab the existing pods that are being brought up now. There's just that one. I'm going to spit that out to YAML again. And what you'll notice is that this pod has that same spec that we saw in the deployment, we have the CPU limit, but now we have an environment variable injected. In the DOCT clusters, we inject Gomax Procs based on the CPU limits, because in Go, Go is built for concurrency and parallelism. They're language idioms in Go, but these DOCT nodes that we have are the clusters are typically about between 7 and 45-ish nodes in a cluster, and every one of those nodes is between 24 and 48 CPUs. So the way that containers work, it can see that there's 24 or 48 CPUs on the node that it's running on, and the Gomax Procs, which is just the level of parallelism that's possible in Go. Gomax Procs is automatically set to the number of CPUs that you have. But if you've limited the CPU to only being able to use one CPU's worth of time, then having a parallelism level of 48 or Gomax Procs of 48 is going to cause the runtime to do a lot of thrashing between threads when it can't actually get all that time. So what we want to do here is we want to set Gomax Procs to 1 so that it's congruent with the CPU limits that are in place. So that's exactly what we did. We just automatically injected that. And so you can extrapolate this and think about, okay, well, how would you inject environment variables that others might want to know about, or volumes, or any number of things you might want to adjust to either protect the health of your clusters or let applications know something about the environment that they're running in. And so the same technique we're going to talk about today could be leveraged for all those other kinds of use cases as well. So the way this happens is we deal with a Kubernetes dynamic admission controller. In this case, it's a mutating admission webhook. What happens is that the Kubernetes API server will, when it gets a command to create a resource of some type, will contact our webhook and get back a way to patch that particular resource. Kubernetes will apply that patch and then create the resource in the cluster. The way that happens is through a mutating admission webhook. Mutating admission webhook configurations. So YAML, we only have one in this case. Now, this mutating webhook configuration, what it does is it describes to the Kube API server, to the Kubernetes control plane, how to contact a webhook. It's the important bits here that you really need to worry about is the webhooks property, which has an array of admission review versions. In our case, the admission review version that we want to focus on is this last one that's in this configuration. We will talk about the other two that are in here in just a minute, but the base one is this last one. And it describes a couple of things. There's a client config, which is really to let Kubernetes know what URL it should send a request to whenever some event for a particular kind of resource happens, and a CA bundle. So this is a certificate authority bundle that tells Kubernetes that when you make that connection to this URL, this is the certificate that you can trust. So that's configured in the cluster as a Kubernetes resource. It's called a mutating webhook configuration. We should configure a failure policy. The failure policy is going to be one of either fail or ignore, which means that if the webhook returns a non-200 status code, then what should it do? If the policy is fail, then it's just going to deny that operation and say, no, I just can't do that. I can't create that resource or delete that resource or update that resource, whatever the case may be. We specify a name, so every one of these these admission reviews needs its own distinct name, and a namespace selector and object selector, and these describe when to apply this particular rule or this set of rules. A namespace selector matches on for this admission review. Basically says, hey, as long we want to use this rule, as long as, or we want to use this webhook as long as the KH webhook allow webhook failure label does not exist. Object selector, we do the same kind of thing because the way we've constructed this webhook, it can operate. You can set it on whole namespaces. You can set it on individual objects. So like if you have some object or some namespace where you don't want this webhook to run, or where it doesn't have to run, then you can use these object selectors and namespace selectors to control when the webhook is called.
Hey, Billie,
Then
could
we
you give
have
an example of why you wouldn't want a webhook to actually run on a resource?
Yeah, thanks, Ben. So you wouldn't want a webhook to run on a resource if it might potentially cause some sort of problem, or if you've already configured the resource to do that, or if you've already configured the resource to have the same kinds of things that the webhook might do. You might also not want it to run. You might not want the webhook configuration. You may not want the webhook to run on the webhook server itself. If you have, like, you may not want this to run on the kube system namespace, right? Which we know generally, hey, this whole namespace doesn't need all the things that we might be injecting at Gomax Procs and volumes and volume mounts, because those things are built just to run in the cluster and don't really need to know about the larger kind of environment that the other applications in the cluster might need to know about. So in those cases, we could put, like on the namespace selector, we could, in the KH namespace, we could put the KH webhook allow webhook failure, and then we can make that would allow the webhook to fail if it failed for some reasons. That way, we don't end up in a situation where the webhook server is not running, and then therefore we can't run our other components in the kube system namespace that we expect, like the kube API server or node controller or node export or something like that. You want those applications to be up even if your webhook doesn't come up. So you might want to put a namespace. You might want to put a label on your namespace to allow the webhook to fail in those cases. So we specify which things this is going to apply to. These are resources. In this case, it's just going to be pods because we're just going to be modifying pods today. But you could do config maps, you could do deployments, you could do stateful sets, you could do secrets, you could do pretty much anything you wanted to here. And then operations. In our case, we're only going to worry about creates because we're injecting an environment variable, and we don't need to worry about updates or patches or deletes or anything like that right now. We just want to make sure that these pods get this Gomax Procs environment variable. You can also restrict it even further by API version. So if you had, let's say you had some kind of resource that was changing, or where something had been deprecated, and you want to make sure people didn't use it, you could, for instance, say, hey, for that one particular API version, this one feature of Kubernetes doesn't work the way I expect. So if somebody has that, maybe you want to change it to be something else for some kind of fix. So that's what our webhook configuration looks like. I do real quick just want to cover that we have other administrative views in here as well. Remember this one, we only have two selectors, one for the namespace and one for the object. Each of them just check to make sure the K8 webhook allow webhook failure does not exist, and they have a failure policy of fail. There's other variations of this that we automatically create, that this webhook server is going to automatically create. Two variations. The first one has a namespace selector that does exist, and the object selector does not, in which case we're going to have a failure policy of ignore, which means that if the namespace has the K8 webhook allow webhook failure label, then the webhook is allowed to fail. So anything that's deployed to this namespace, it's okay if the webhook fails for some reason. And so that'd be the kind of thing we might want. That'd be a label we might want to put onto the kube system namespace. Then we have a similar variant that has a failure policy of ignore again. And this time we're checking to make sure if the namespace selector does not exist, but the object selector does. So this would be the pod itself would have this K8 webhook allow webhook failure policy or label. So there's three variations: the base variation, and then two that are created from it to allow webhook failures in some cases. Any questions about any of that? All right.
No questions in the chat.
Cool. All right. So there's the amount of code that we have here it's kind of substantial. I've simplified this down quite a bit from something that we actually do run in DOC cluster. So the code you're seeing here today, you may see some features of it that you're like, well, why do you need that for this particular case? And the answer is we may not. But this is distilled down from a larger project so that we can focus just on the Gomax Procs webhook. But this application is built to be able to support many webhooks. I should also step back and say there's two kinds of webhooks in Kubernetes. There's the mutating webhook, and then there's a validating webhook. Mutating webhook is to change a resource upon some operation before Kubernetes puts it into the system. Before Kube API server submits it to the scheduler. The other kind is a validating webhook, and the validating webhook can be used to just deny or allow a certain thing. So, like in the DOC clusters, we have validating webhooks that prevent people from using host network, or that prevent people from mounting host paths on the nodes, because these DOC clusters are large shared environments, and they don't belong to any particular team. So we want to make sure that the underlying platform that it's running on, those underlying nodes, aren't accessible to the applications that are running on those clusters. But today we're just going to focus on the mutating webhooks. The validating webhook is very similar in how you configure it and how you run it. It's just a slightly different implementation in the final step of making the change and what the handler has to do. But if you understand all the other things that we're going to talk about today, then creating a validating webhook is relatively straightforward to do. So here we have a simple Go application. We're going to execute a function to create a new configuration. Then we're going to pass that configuration to a new controller constructor. We'll set up some signal handling here, and then we run our controller. And this controller in this case is just really a thing that has a run method. And it's going to execute all of our handlers. There's a couple of things we want to talk about in the config, so let's jump over to that. We set up flags because this is an application like any other. And there's a couple of things that we want to configure, which webhooks we want, what the webhook base URL is. This one's pretty important, as we'll see in a minute, because the way we describe each of these webhooks in configuration in the application doesn't have the webhook base URL, because the base URL is going to need to vary depending on where we deploy this application. So we have the base URL, And then we have to get a Kubernetes client. If you've dealt with these before, you know that so kubeconfig is just a rest.config, which we got from, where is it? Here we go. When we're running in the cluster, we'll call this method that specifies the queries per second, how much you can burst, and what the user agent is, and that just gives us some information so we can tell who's calling our server whenever Kube API server calls it, or sorry, vice versa. Whenever this application calls Kube API server for reasons, we get a Kubernetes client with new for config. We need a certificate, and that certificate is required so that Kube API server can securely contact our webhook, and we're not going to be vulnerable to traffic getting intercepted and changed in flight. And then we pass that certificate directory and the CA bundle off to Runtime Manager. Runtime Manager is a function here that creates a controller-runtime manager. If you've dealt with controller-runtime before, this will be old hat to you. But for those of you that haven't dealt with controller-runtime or that have never built any kind of controller in Kubernetes at all, controller-runtime is kind of the next step in the evolution of writing controllers for Kubernetes. Controllers typically in the past have originally had to rely on watchers, and then they abstracted watchers into informers, and now informers are being abstracted even further into controller runtime, where it just makes it really easy to watch resources, reconcile resources, create a bunch of webhooks, and so controller runtime is becoming the place where modern controllers are written. Whenever you create to deal with controller runtime, you typically are going to have to create a manager, and this type is it's just a manager type from the controller runtime special interest group, or it's a package. You can get it like their sigs.k.io controller runtime package manager. We have to pass it the scheme, which in this case is going to end up being TLS, a certificate directory, so that it can find the certificates that's going to need, and which port we're going to list on. There are other options that we can deal with, but we don't need to worry about those today. One of the things that we pass here is the scheme. If you have a controller runtime controller that needs to reconcile custom resources, you want to make sure that you add that custom resources scheme to kube scheme here. And so you add all that. That way, whenever controller runtime takes a look at the scheme, it can see all the resources it needs to, and it can actually reconcile all those different kinds of resources. So once we have the runtime manager, then we basically complete the configuration. Then we're going to pass that configuration off to this new controller constructor. Again, this is relatively simple. We are simply taking this config value that we have and passing each of those values into the controller to configure it the way we need it to be configured. Again, we're going to set up cancellation context to handle signals, so that if this application is sent to sig term or sig quit, or control C if you're running it locally, that it'll shut down right away. And this is important in Kubernetes, because Kubernetes, whenever a pod is going to terminate, Kubernetes will first send a sig term signal or a term signal to the pod. It will then wait up to termination grace period seconds, which by default is 30. It will wait up to for that amount of time for the pod to terminate itself. After that, it will send sig kill. So by handling signals, you can make sure you don't accept connections that are sorry. Make sure you gracefully stop, so you drain existing connections before accepting new ones. It also makes sure that a request doesn't get terminated in flight because it got sent to the server, and then the server gets killed while it's still processing it.
So just to be clear, this isn't required for a webhook, right? This is just good practice.
Yeah, that's right. Yeah, the signal handling is just good practice. It's not required for the webhook handler here. We really do this because we're going to run this server in the Kubernetes cluster. So the cluster itself is deploying and managing these pods, and so we want to follow those best practices for a Kubernetes application. Okay, so then ultimately we call run, right? We've configured the controller with a controller runtime manager. We've given it a logger. We've given it the webhooks that we need, etc. And now we actually want to run this thing. So we call controller runtime.set logger because controller runtime itself will log messages when certain operations happen. We just want to make sure we have consistent logging, both for logs that are coming out of controller runtime itself and for they're coming directly from our application. So we set that logger there. And then we want to go register the webhooks. Now, this name is really about registering the mission reviews or the particular webhooks they're going to be executed. This is a relatively, again, all these functions are try to make them pretty small so they're easy to grok. We need to get the webhook URL for this particular webhook. And so you can take a look at this. Again, this is straightforward. We grab the configuration for this particular webhook. We'll take a look at that map here in just a minute. We parse that URL out, and then we resolve that reference against the base URL. And that gives us a fully qualified URL that you might remember we saw earlier. I'll show you here. So that's what we're building, is we're building this URL here. Yeah. Get back to the same place that I just left. 1 second. So these webhook configurations, remember, we pass in here, we just pass in the name of the webhook URL that we want to manage. So we maintain a map of these webhook configurations in code that they describe those things that can vary between our webhooks. That's going to be the path. And so this is the relative path. This is why we have to do the resolve URL reference. You could have some other path here if you wanted to. The failure policy for this, how to handle reinvocation, and then the rules, right? So again, failure policy is going to be one of either failure or ignore. Reinvocation is going to be if needed reinvocation policy or never reinvocation policy. So it's reinvoke it if needed or never. So that really means that if another webhook modifies this resource, then recall this webhook again, at least one more time. Never would say, hey, once I do my thing, we don't need to call it again. If someone else changes whatever I might do here, I don't care. So in this case, we want to make sure that if some other webhook that gets called removed the Gomax Procs, we want to put it back in this case. So we use if needed reinvocation policy.
So Billy, you had shown 3 webhooks earlier, but we just saw 1 there. Can you explain how you get 3 out of that?
Yeah, that's a good question, Ben. So that ends up happening down here in register webhook configuration, which will, so I realize I'm jumping around. I'll tie this together a little bit better for you here in just a minute. But we grab the mutating webhook configurations and then we upsert them. But those webhook configurations, again, it's going through our mutating webhooks that we saw. So this is that that map that we have. It's going through each of the webhooks that we've configured, grabbing each webhook's configuration from that map, right? And this is the base one. So this is the very first admission review element that I showed you in the mutating admission webhook configuration. This is the one that does not exist on both the label and the object selectors. And so we grab that configuration, and then we're going to create a couple of variations, because we know that if the policy is fail, then there are times that we want to make sure that it has an ignore policy. So we want to create a variant of that same policy that is that where the label does not have the sorry. So we put this failure policy on both the handlers. We put this policy. How do I say this? We have the webhooks that have the fail policy. If they have the base webhook has a fail policy, then we're going to add match expressions for both the object and the namespace to only apply when those labels don't exist. And then we create variations. Where do I have this here? Are you seeing it, Ben? Mission reviews, reinvocation, failure policy. There we go. Yep. And then so that gives us the original handler, and then we take ignorables, and it says, hey, if the failure policy doesn't exist or it's already ignored, to just don't do anything else. But if the failure policy is fail, then we're going to create variations to allow us to ignore the webhook for namespaces and or for objects. So we create those additional webhook configurations by deriving them from the configuration that we specify in code. Does that make sense?
So at this point, then you've got the base one and the two variations, at least for the Gomax Procs example, right?
That's right. That's right.
Cool.
So once we have the Gomax proc URL, we then have to get the webhook server from the controller-runtime manager, and we just register a handler for a particular path. We have an emission value that takes I'm going to stop wrapping this so it's a little easier to read. So we register for a particular path. We create at that path, we're going to have a handler that we specify here. We use a new mutate pod strategy handler. That's a thing that exists in this code base. I'll show you here in just a minute. Because remember, this whole system is really bigger than what we have here today. And so in order to reduce boilerplate, we use a strategy where we can then just inject the small thing that needs to actually be done. The main work that helps us reduce boilerplate. So we can go take a look at that mutate pod strategy handler. And this implements the handle method that the admission value that we're registering needs. This handle method takes a context and an admission request. The admission request describes basically in raw form the resource that's being operated on. And so we need to decode that to get a value that we can actually work with that has methods and properties. So first thing we do is we have to decode it, and then we mutate it. And this mutate is the function that we pass in to actually do the work that we just talked about. And so in this case, that work would be injecting the Gomax Procs environment variable. We then take that result of what we've mutated, marshal it to JSON, and create a response this admission.patch response from raw is provided by controller-runtime. And what it does is it creates a response that contains a patch that describes the difference between the original raw value and what we've now marshaled. Real quick, I want to go take a look at new mutate Gomax Procs so you can see what this does. So this is the real work of the handler that we want to do to handle the creation of the Gomax Procs environment variable.
So this is the part that would be very different between different webhooks, right?
That's right. Yeah. So the mutate pod strategy that handles all the boilerplate, and this set Gomax Procs here. Remember over in on this line where we're registering this particular handler, we call new mutate pod strategy, and the last thing we pass to it is the result of this new mutate Gomax Procs constructor. So if we go take a look at that, all this new mutate Gomax Procs constructor does is it returns a mutate pod, which is a simple function that takes a namespace and a pod value. And we're just going to it turns out that our set Gomax Procs function is a mutate pod or satisfies mutate pod. So we just return set Gomax Procs. And this is, be clear, like this is not returning the result of set Gomax Procs. This is returning the set Gomax Procs function itself, because in Go, functions are first-class citizens. They can be named. They can be assigned to variables. They can be passed around as values. So we pass that function value off to the handler, and then to the new mutate pod strategy, and then that mutate pod strategy will end up calling set Gomax Procs at the right time after it's done some of that boilerplate decoding of the pod. So for this case, what we're going to do is we're going to iterate through all the containers in our pod spec. First thing we're going to do is we're going to say, hey, if Gomax Procs is already set, don't do anything. We're doing that because in this case, we're assuming that that the maintainer of that pod knows what Gomax Procs value they want it set to, even if that might vary from what the CPU limit is. Now, you can certainly have an argument whether or not it should be a little bit smarter and say, well, we only want to, maybe if the CPU limit is lower than the Gomax Procs, maybe you'd override it. But in this case, we don't want to do that. And we're just going to take the simple 95% case and say, if you've specified Gomax Procs already, then we're not going to do anything. This also helps us in that reinvocation policy, so we don't do this again if it doesn't need to be. So we figure out what the CPU limit is for the pod, and if it's 0, don't do anything, because we don't need to set Gomax Procs in that case, because Go will naturally see that there's as many CPUs available as are on the system, and that's what that is appropriate for Gomax Procs in that case. But if you set a resource, it's not 0, then first thing you want to do is we're going to say, hey, have you specified less than a single CPU? Because in Kubernetes, you can specify a CPU limit of half a CPU or a tenth of a CPU, or some fractional value. But so if it's less than 1, we just want to set it to the minimum, which in our case is going to be 1. Gomax Procs is an integer value, so we don't want to set it to 0. We'd want 1 is really the lowest you can set it. Then we do a little bit of integer division on that CPU limit. And finally, we set the environment variable on our container. There are other kinds of ways to set environment variables in Kubernetes. You can do env from, which is you can use to get an environment variable from a secret. We're not checking those environment variables here. Again, we're covering the 90% case. We don't expect people in the DOC clusters to be getting their Gomax Procs values from secrets or anything like that. And then finally, once we've added that Gomax Procs environment variable to the env slice and assigned the result of that back to the env slice, then we're going to assign the container back to the container slice on the spec. And that's really what Gomax Procs does. It just makes sure that the Gomax Procs is set if there's a CPU limit, and that it's not less than 1. So we've registered that handler, and now we need to register this webhook configuration. Ben, this is what you were asking about earlier about those variations. So again, this goes through and grabs our mission webhook configs, iterates through all of them, configures them, basically creates that mutating webhook configuration, and then we just upsert it. So again, here we're going to see if it already exists. If it does not exist, then we're going to that's actually two lines. Okay. So if it actually doesn't exist, we're going to create it. If it does exist, then we're going to update it. Then we need to register some handlers here. These handlers, you could skip this. This is for other things, like if you want to register a Prometheus handler or some other kind of handler to do other kinds of things in this server. Then we're going to execute all those handlers in a Go routine. So once we register all those handlers in a Go routine, I'll point out too that we're using an error group for this. So EG is an error group with a context. What we pass the context because remember we can do cancellations or handle signals. We need all these Go routines to respond to that. And then we wait for all those handlers to be done before we finally return from our run method. So we've configured the handler, we've configured the server, we've created the webhook configurations and inserted those into Kubernetes. So Kubernetes knows, hey, here's when you go to create a pod, call this webhook. And that's pretty much how you create a new dynamic emission controller to mutate a pod in Kubernetes. Again, you could use this for pods, you could use this for deployments, you could use this for any Kubernetes resource. Exact same techniques. And this is a lot simpler than the old way we used to have to do this, where we'd watch for a pod to be created and then modify it, or delete it and replace it or something like that. Or you might have to, you might have to do the same kind of thing with a deployment, so your pod should be created the way you expected. These dynamic emission controllers allow custom logic to be put into the management of resources in Kubernetes. So that's how you can really eliminate a lot of toil and tribal knowledge. Like, you don't have to worry anymore about making sure that all your users know that that they need to mount a volume from the host that contains the TLS certificates for your intermediate certificate for your internal CA or anything like that. We can just inject all of that, so people can just rely on the fact that they can that's going to be there. Now, one of the great things about controller runtime is the test that it has. So we've written unit tests for these functions or for this controller. And real quick, I just want to show some of the things that controller runtime makes available for testing. So first off, we have just kind of regular unit tests. And you can see, I don't know, we have probably 15 to 25 tests that we actually run for these. But we can get a little bit fancier and use this package that controller runtime provides called env test. And env test is really nice in that it allows you to run your controller code or run your tests against a real kube API server and a real etcd. Now, the rest of the Kubernetes control plane, so you don't have to worry about that your pods are actually going to be created, like there's going to be any resources being consumed on any real node. You don't have to connect to a real cluster, but you have a very, very minimal control plane that consists just of the kube API server and etcd, so that you can contact that kube API server and actually exercise all your code and make sure the result is what you expect once the application is created. So remember, we had a relatively small number of tests here whenever we don't do the sandbox tag, and we've protected the tests that require kube API server with a sandbox tag. You might call that tag integration or AD or something like that, depending on what your organization's preferences are. So we get quite a few more tests here, and we get all this output from etcd and from kube API server, so we can really see what they're doing in cases where we might have some problems. Let's go take a look at what that TestEnv setup looks like. Let's see, it's integration test. So I named this thing. So in this case, We have a simple function to test the creation of our Gomax Procs environment variable. And this is, again, this is a very simple test. We really just want to make sure that we're going to have a pod that we're going to be creating. This pod has resources, but no environment variable set. And so we're really just calling create on that, which passes it off to KubeAPI server, and then KubeAPI server returns does take some action. It's going to ultimately create that pod resource in etcd and make it available to other readers of KubeAPI server. And then so ultimately, then we just want to say, hey, the pod that I got back, does it have Gomax Procs set? And again, remember, we did not set that environment variable in the create when we call the create method. So the only way for Gomax Procs to be set here is if our controller or if our handler worked. So we have a couple of things. So we have with TestEnv, which configures a test environment. I need to go build tags sandbox. With TestEnv is a function that takes a testing.t value, a function to execute, and then some options. And we're going to call new TestEnv to create the test environment. This is going to give us a KubeAPI server and etcd instance for each invocation of new TestEnv. And then we're ultimately just going to call that worker function to actually execute the true test code. So I didn't mention earlier, but one of the nice things about having this KubeAPI server and etcd is I can really isolate all my tests from each other to make sure that they're not there's no side effects of one test on another. So new TestEnv spins up a KubeAPI server and etcd, and we call this for each of our tests. And creating a TestEnv is pretty easy, or an env test is pretty straightforward. This env test environment comes from controller-runtime, and it has a control plane and a scheme and a config and all these various options. You can set up CRDs, etc. We don't need all of that. We just need the CRD install options, which we're going to say, hey, if we do install any CRDs, custom resource definitions, make sure you clean them up after we're done. That's useful if you're reusing this test environment. Right? So if you have multiple tests that might be using this, then the control plane output we're going to hook into the testing.verbose. That way, all that KubeAPI server and etcd output we don't see unless we pass -v to go test. Then we configure the API server. One of the things you can do is you can add in additional arguments to KubeAPI server if you want here. There's a I think it's a configuration that comes off of API server. Is that right? Yeah. So you can so you can pass additional things to configure. Sorry about that. And I'm not sure where those arguments come from anymore. Are they here? It's not this config. It would be. Now I'm completely missing it. I don't remember, but there's a way you can pass additional arguments. I just don't recall exactly what it is now. Oh, sorry. Yes, I do. So you call configure and you get back your arguments, and then you can use those arguments. You can append to that argument slice before you call start. Start is the thing that actually will start etcd or launch the etcd process on the KubeAPI server processes. And then this function, remember, we're setting up the whole environment. And so, yes, we started etcd, yes, we started KubeAPI server, but now our tests might need to do some things, or the client that we configure for it might need some configuration. So we're going to handle all of that and pass that back to the caller. So we get back a REST config and a kubectl, and then a stop function as well. And then we call the go test max procs, and that's it. So the nice thing about one of the nice things about controller runtime is it makes it really easy to test Kubernetes controllers holistically, where you don't have to just rely on unit tests. You don't have to rely on the Kubernetes fakes that exist in client Go. You can actually be testing against a Kube API server and etcd to make sure that your mutating emission webhooks and your validating webhooks truly have the right configurations, and that like this also tests that your mutating webhook configuration is correct, right? Because Kube API server, when we configure it, part of that TestEnv, that new TestEnv function, it configures the controller, which adds the mutating webhook configurations to Kube API server. So you're making sure that all that is correct. Whereas in most unit testing kinds of frameworks, you wouldn't have the ability to test all of that, and so you have to rely on, either some manual testing or some end-to-end testing. And the nice thing about this is like you can do this on your box as a developer. You don't have to have you don't have to rely on CI or some kind of larger shared environment or setting up a real Kubernetes cluster or anything like that. And all you need is the etcd binary and the Kube API server binary. So real quick, where I did this kube builder assets environment variable, that's a feature that env test from controller runtime expects. It'll look in that location for etcd and Kube API server binaries. If you want to use this, then you can get etcd binaries from the etcd project from the releases on GitHub, so you can use the same version of etcd that you're actually going to be running in your clusters. And Kube API server, similarly, you can make sure you're running the same version to get the Kube API server version that you need. You might need to check out the Kubernetes project, so that's github.com Kubernetes. And then you execute make Kube API server to build a Kube API server binary for your system. So I'm on a Mac, and I'm running Kube API server on my Mac. It doesn't require Linux. You don't have to use a precompiled binary. You can just do make Kube API server on your Mac. It'll build it for your Mac, and it just works. I think that's all that I have for Kube API server and controller runtime. Or sorry, that's all I have for these mutating emission webhooks. Do we have any questions? Do we need to go back
I don't
over
see any
anything?
yet. Perhaps you could talk about, so obviously the testability of those registration is a big asset. Are there any other benefits over just having like YAML? You don't have to write all that code to
Yeah,
generate what's essentially
yeah,
just like again one YAML file.
yeah. It's good question. So I personally like you'll see a lot of people, and even the Kube Builder project seems to advocate for putting YAML separately. And YAML in Kubernetes is used to describe all your resources, right? It's used to usually Kubernetes manifest, and you just kubectl apply it. The problem with a mutating emission webhook and that you're running in the cluster, right? So in this case, we're running these mutating emission webhooks in the cluster. If we store the YAML separately, then you have a pretty big timing problem where either you need to deploy a change to your webhook, right, and then go update the YAML and apply that, or vice versa. In either case, you can get in a situation where things could be failing in that time period where they're not in sync. It also means that there's this locality of reference problem where the YAML has to exactly describe what you expect to happen, and you have to hand code it all. By using this, we get by making our webhook or our controller manage that webhook configuration, we get a couple of things. One, we know that when I deploy this change, the webhook configuration is going to be updated right away, and that it's going to be updated to work with this version of the webhook that's actually running on the in the process. And then we do DigitalOcean on the DOC clusters. We do this for several things. Like we do this for our webhook configurations. We do this for our custom resources. So like if we have a controller that is managing reconciling custom resources, that controller controls the custom resource definition, and that really just makes sure that whatever that definition says, that matches what's actually going to be running and what the controller expects. Same things with the webhooks. We have these mutating mission webhooks, these validating mission webhooks, and in both cases, the configuration for those webhooks is managed by the webhook itself to make sure it's in sync and we don't have any impedance mismatches between the configuration and the actual implementation.
Cool. So we got a question from YouTube from Shahar asking, oh, here you go, it's up on the chat. Do we have a sort of duplicate end-to-end thing for CI, kind of like what you showed with your env test?
So sort of. So remember these integration tests, all they need is a Kube API server and an etcd. So we do run these in CI at DO, and we have a container that has the version of Kube API server and the version of etcd that we need, and that matches what we're running in production in the DOC cluster. So if we update Kubernetes, one of the things that we do during that process is we update the container that we use to use the same version of Kube API server that we're going to be deploying. If we do an etcd upgrade, do the same kind of thing. And that way we can actually test, hey, yeah, this Kube API server doesn't have problems with these webhooks or with these custom resource definitions or whatever. So as long as you have Kube builder assets set, and that points to a path that contains your Kube API server and etcd binaries, then you just execute go test and you're off to the races.
Cool.
Thanks, Shahar.
Any other questions? Throw them in the chat. We can see them related to Gomax Procs or webhooks or anything else we've seen from Billie.
Okay. So just to kind of wrap up here, if there's no more questions, if you're still typing your question, or if you have a question you haven't typed it yet, feel free. But in the absence of that, I'll say that we've covered like how to use these mutating webhooks. Again, you can use these to reduce toil and tribal knowledge in your Kubernetes clusters and really simplify the experience for a lot of your users. So if you're managing Kubernetes clusters and you want to abstract away a lot of the toil that people might have to configure volumes or configure environment variables consistently, you can use these mutating webhooks to make sure that all your applications have this, and none of your users have to know how to configure these things in the pods or deployment or stateful sets, etc. So thanks for coming, everybody. I hope this was useful.
Thanks, everyone. Signing off.